everybody, and thank you so much for joining me here for another YouTube video on my channel. Now, this is another end-to-end tutorial. It has been a while since the previous end-to-end tutorial. In the meantime, I have done several live streams, so do let me know on those live streams as well as on my other videos what you would like to see, what kind of end-to-end tutorials you would like to see next. I would love to hear it. Now, this video is on Notary. Notary is a CNCF incubating project with a long history, and we will look a little bit about that history. Now, this video is about what Notary is, as well as the different resources that are available and how to get started with Notary. Notary is used to sign things. In its most simplest terms, you can sign with Notary your container images to basically state that this container image is built by you. It's verified by you. So you have Notary as the Notation CLI installed on your local environment. We will look at all of that. And then you build a container image, and then you sign that container image with Notary. And from that moment onwards, you can give other people something called a trust store with like a verification that that image has been signed by you. So people can then access this public information and verify themselves that that image has been signed by you. Now, the chicken and egg problem is here that once container images are signed, independently of how they are signed, what you will have to do next is distribute this public information. Anybody who has the public information can verify that the container image has been signed by you. Now, the private information, such as the private key that you use to sign that container image, stays always with you. So nobody can replicate signing that container image and pretending to be you. Now, that's very, very useful across your supply chain security. Your supply chain is basically any resource that contributes to the development, any resource or process that contributes to the development of your software project, whether that's like the infrastructure, the physical components, actually as well, not just the software, or any software component that's feeding into your development process. That's all part of your software supply chain. And the thing is, software supply chain attacks have been going up. And there are more and more sophisticated software supply chain attacks. And linked below are some examples of supply chain attacks that have been really interesting. I'm not going to go into detail because that's probably part of another video. But the overall TLDR, as a summary, is that you have to make sure you know what's going into your projects, what you actually deploy, what you actually run, and you have to basically verify these. So instead of building your project and then at the end saying, okay, is everything I put in actually legitimate? Like, is it legit? Is that actually verified from trusted sources at the end? Rather than doing it at the end, do it throughout your development, throughout your software development lifecycle. Whenever you use a new resource, verify that resource. So you're basically filtering out any malicious resources throughout the development process, because once you've developed your project, you've deployed everything is working. First of all, you will be in a different mindset to actually change things up. But also, if you do change things up and you actually want to verify each component, it becomes a lot more difficult. So do it throughout your development process with projects such as Notary. Now, there are other projects as well that you can use to sign your container image and your artifacts. For example, Cosign is one of those projects. Also, our open source security scanner at Aqua Trivi integrates with Cosign. You can find some tutorials that I've made in the past, linked below in the description as well. Now, as always, this video has a written description. Here is the draft of the written tutorial. As you can see, it's very long with lots and lots of detail. So do check that out if you're curious about the written content. Now, Notary as part of the Cloud Native Computing Foundation. It's part actually since 2017, and it's now at the incubating level. Let's visit the website that's linked here. Cool, that's the website. Now, the thing is that there's different types of notaries. So basically, there's a Notary version 1 and then there's a Notary version 2. Version 1 was accepted into the Cloud Native Computing Foundation, and you can find it as well, if you look for Notary, you can find it here. This is the Notary version 1 project, and it's called Notary. And that's why it's very confusing, because basically once you Google Notary, you will see, the first thing you will see is Cube Notary. And Cube Notary requires you, this is Cube Notary, which is an open source project, but it requires you to actually be signed into this Code Notary cloud thing that you have to pay for, it seems. I didn't check it out in detail, but if there's a trial, then you probably have to pay for actually using it. So that's Cube Notary. And that's the first thing you will see when you look for Notary. Then you have, basically that's part of Code Notary, this Cube Notary, this whole thing. And then you land at a detailed tutorial, but this is still using Notary version 1. Now the problem with Notary version 1 was, as far as I understood, that it uses the update framework under the hood. The update framework aims to provide a framework, a set of libraries, file formats, and utilities that can be used to secure new and existing software update systems. These systems can be package managers that are responsible for all of the software that is installed on a system. Updaters that are only responsible for individual installed applications, or software library managers that install software that adds functionalities such as plugins or programming languages and libraries. You go on. So it's basically a specification that Notary implemented. So tool to publish and managing trusted collections of content. And with Notary, you could then basically verify that any updates, any changes, any components used are verified. Now, the thing is, then Notary version 2 was released, and that's what you find next. If you go to Notary project, actually, you can find Notary version 2. And the thing is, when you're at version 1, you don't really see much to it. So this is kind of my comments on Notary. So it basically says it got moved to the update framework, but if you click the link, it's just leading you back to this project. So it didn't get moved. So it's very confusing, this whole thing. But eventually you will end up at this page and you will find, okay, there's something called notation, and there's, well, the Notary project. Yeah, and the Notary project, which is the version 2, a current overview of Notary version 2, including a collection of requirements, scenarios, framing the scope of Notary version 2 project. So this is what you should be using, because version 1 is not actively maintained. It doesn't have an active community behind. So use Notary version 2. And here you have, as part of Notary version 2, to use it, you have notation, which is the CLI that allows you to sign container images. That's basically what it does as of now. And this is pretty much the overview of what you can find right now on Notary. Now, I'm not going to go into the details because it's not really, like, I don't think we would gain much out of me describing the details on how I understand Notary works under the hood. But we're going to go through the CLI and actually sign our container image. So this is the overall idea behind Notary. And this is like a screenshot I took from a presentation I could find. Now, this is on Notary version 1, but it didn't really change as far as I understood to version 2, like the principle behind it. So basically, when you want to use a container image, you usually go, hey, to the Docker daemon, hey, could you please access this container image? If you don't have the container image locally, because, for example, you didn't build it locally, then Docker goes ahead and, for example, pulls it from the Docker hub, from a container registry, and just pulls the stuff straight down, right? So you oftentimes don't really know what you pull down, like what you are actually accessing, what kind of resource you're accessing. So what you can do instead is, with something like Notary, you can be, hey, is this container image, is this just like basically the gist of the container image, digest? Is it signed by people I trust? And then Notary will be like, here are the signatures that I have for this container image. And then you can be like, oh, I know, for example, Bob's signature. I have used other resources from Bob before. I can verify it against the public information I have from Bob, that this container image has also been signed by Bob. I trust Bob. Therefore, I will I will use this container image. I trust it. Now, obviously, here's the chicken and the egg problem, because you need to have some publicly verifiable information on either of the signers of that image, of that artifact before, to then be like, hey, I trust, for example, Bob, and I want to actually use that artifact. So the signature checks out. It all matches. My public information matches what public information is available on that image signature. I can verify that this is actually Bob who created it. And now I'm feeling confident to pull the information from the remote container registry, and I'm not just pulling down sketchy stuff. So starting off, how do you actually install Notation, the CLI, to use Notary? Well, you have to go to the releases. So go to the latest release. And then you will have here a list of different zip files, different installation options. So get the one that's for your machine. In my case, I'm 64, so I downloaded that one. And then I have detailed instructions in the blog post on how you can unzip it and install it. Now, once installed, you have to make sure that you have access to Notation. So here, Notary version 2, a tool to sign and verify artifacts. And here you will find the available commands. Now, once we have Notation installed, we have to have a container image in OCI compliant container registry. OCI is the container interface, Open Container Interface, Open Container Initiative, something along those lines. Anyway, it basically specifies certain capabilities. Container registries should have to be compliant. Now, Docker Hub, for instance, does not work as of now with Notary version 2 because it's not completely compliant. What a bummer. So what we're going to do is we're going to use the GitHub container registry. It's super easy. I'm going to walk you through it. So first of all, you need a Docker file and build a container image for that Docker file. So for example, in this case, I have here a Docker file for this website. It's my cloud native security website. So this is basically my website. It's just an overview of different cloud native security focused projects. Very fancy. Anyway, this is this website, right? And we have a Docker file in here that we can build. And we're going to build it as follow. Docker build x, build, and then the tag is a nice early CNS website. Let's update that tag to do 1.2. And then the different platforms that I want to build this container image on. Now, since I want to build it for the GitHub container registry, I have to add here additionally the container registry that I want to use. And I actually also want to use directly the repository. So instead of specifying my Docker Hub handle, I'm going to specify the GitHub container registry. And then this is the name of my organization. It could also be your GitHub username. And then I specify that this is the image and this is the tag, and I want to build it for these platforms. Now I'm going to show you in a second as well of how you could retag a container image that you already have locally to use the GitHub container registry. So what you can do when you already have images available is run docker image ls, and then you can take, for example, this container image, and you can retag it. And that's done with docker tag. Then you need the image tag that you want to retag, which is the image ID basically. And you copy this, you paste it here. And then you need to post what you want to tag it as. So for example, we can tag it as this one. And we want to update the tag at the end. So this is how you would retag the container image. Make sure it works. And then we list them again. And now we have this one here, the 0.1.1, which has the container GitHub container registry tag. So now you might wonder why the image I just built earlier is not available here. Well, because it's automatically pushed to the Docker or like to, it's automatically pushed to the remote registry, so I don't have it available here. So what we can do next, or what we have to do next, is log into the notation with the Notation CLI. So if we run notation, we can see here log into registry. So we need to log into our GitHub registry. So we're going to do that through the following command. It's basically log in, then the URL of the registry that you want to log into. Then the username is my organization and the password is a personal account token. And this account token does not work, but we're going to replace it. I'm going to show you how you can generate a personal account token. And that's the password. So don't put the password, put your personal account token here. So we're going to go over here to your settings, to your account settings. And then you go here all the way down to developer settings and to personal access token. And you do the classic one and generate new token. Confirm it. So we notary demo, and it has access to all of the repositories and to read and write packages and to delete packages. That's how much access we will give it. Generate token. Then we copy the token here. I will revoke it after this, so don't even try to use it. And we're going to paste it in. This is going to log in. So you should see login success if the login succeeded. Anyway, this is that. So we are logged in. There's also the GitHub documentation, which is linked below in the blog post as well, if you want to have more detailed information. So next, we want to list all of the signatures of our container image. And we're going to do that with copying the container image. Where is it? The tag here. This entire thing. We want to list all of the signatures that are currently on that container image. Oh, we need to push the container image also to the container registry. So we're going to say docker push. And then we're going to specify these. And now it's pushing to the GitHub container registry. And now we can list all of the signatures on the container registries. As you can see, here are no signatures yet listed because this image has not been signed yet. So there are no signatures. So if the container image has not been signed yet because you just built it, for example, then please, you should not have any return information there. So next we need to create a certificate. And the certificate is basically the name of your trust store. And that's going to be, in my case, anasul.com. Now, this name I already created that. So you could, for example, replace it with cloud native security.com, I guess. So now it created the key. And it's basically set it as default. Now we can list all of the keys with notation key list. And here we will see the new key we have set in our trust store. Basically, this is going to be the default signing key now. And I have these other signing keys as well, created prior. What we need to do is sign our container image. So let's go ahead and say docker image list again. And we sign a container image with notation sign, and then we can sign a container image. So this is the container image we want to sign. It will automatically push the signature to your registry where that container image is from. And basically it will use the default key if you don't specify a key. So we want to sign it. Successfully signed, and this is the SHA, and we need this basically to verify this information, to verify with like the SHA 256, instead of the image tag to verify that this container image has been signed. Because ultimately this number doesn't change. This is a unique number for that container image tag that has been built with this tag, basically. Like this is the really unique build of that image, like the very unique container build of that image, if that makes sense, hopefully. And you can push another image that has the same tag to the same container registry and kind of override the tag that has been there before. But ultimately, this number will then change for the new tag. So while the tag will stay the same, when you update it, the number will change. But for our old build, the one we want to sign, the one we want to verify, this SHA will always be the same. So when you verify somebody else's container image, you need that SHA thing. How are you going to get it? So if we go back to this and we go to packages, we will see here our packages, CNS website, and we will see here the new tag that we pushed. So this is basically the old one that we used, and this is the new one, the SHA, and this should be the same SHA as this over here. Like these should be identical, and that's where you can get the SHA to verify the container image. So this is also where you could pull it. Anyway, so we want to verify that this image has actually been signed. So first we can look at all of the signatures on that container image with notation ls and then the container image. And here we will see that it has signatures added to it. So now that we have our container image, we have signed the container images, we can list the signatures of the container image, we need a way to verify that this container image is actually created by us. And for that, we need a trust store. Now the trust store will be different in in a different location, kind of, in every different operating system. So in my case, I have put it into this is where it is. So it's called the trust policy, and here are all of my keys and everything regarding to notation. And then I want to have the trust policy.json. And take a look at that. And this is my trust policy, okay? This is ultimately my trust policy with everything that it needs. It's a trust policy example. You can define a different scope and the signature verification it should use. And here is my trust store. Now, the previous example did not have the trust store, so we need to update this. Because we actually used for this container image, we used a different trust store, right? So we need to actually put here the different trust store that we used. You will need to update that in yours as well. Now, you can copy paste the file either from the documentation or from my example in the blog post. Here the type of trust store as well. So it's CA and then Cloud Native Security. That's actually how you change it. Okay, let's save that file. And try again. Verify it. Successfully verified signature for that container image. Amazing. So this is ultimately how you get to verifying the signatures of your container images. As always, I really hope this video was useful. If it was, I would highly appreciate if you could give it a thumbs up. And yay, subscribe to my channel for upcoming videos, for new end-to-end tutorials, and to stay up to date with my live stream schedule. Now, if there are any tutorials that you would really like to see, do comment below and let me know what you would like to see in a written tutorial as well as in a video tutorial. I really hope to see you in one of my next videos. Have an amazing day. Bye bye.